Entonces, yo creo que si producción nos da el go, tenemos ahí, tenemos 2 minutos, ahí Bill Bensing, coautor del libro Investments Unlimited. No sé si podemos. Yo voy a switchear a inglés para hablar con Bill, listo, pero los que quieran escuchar la charla en traducción simultánea, pueden ir a la charla, a la sala de traducción simultánea y ahí va a estar siendo Bill traducido al español. Hi, Bill.
Hey, buenos días, Marín. Será todo mi español para hoy.
Ah, va por muy buen camino.
Thanks so much, Bill, for joining us. I know you have a busy agenda. I've seen you in social media, all the things that you are doing or presented. Congratulations on the book, an amazing book. You guys have done it as well. So we have 3 reference books right now: the Phoenix Project, the Unicorn Project, and now Investments Unlimited. Amazing. I think that was an amazing experience. Can you tell us a little bit before we go into that?
Yeah.
How was that experience writing a book for nerd guys like us?
But it was funny. It's funny you say that because like when you say nerd guys like us, I feel I'm one of everybody. And what I loved about writing the book was bringing the realities of my experiences, my stories, and my other co-author stories to everybody. We all have the same experiences in different ways, no matter where we're at in the world. And it's fun to talk about it. And I think what I loved about the book and the great feedback we get is that a lot of people empathize. They feel this, they see this. Sometimes they think they're the only people, but they're not. This is a way more common than it is not common. And so, being able to share those experiences and help people in their environments and in their organizations has been great. And that's it's been amazing. I mean, first time author. Yeah, I can keep going on about it, but it's a lot of fun.
It kind of
Well,
makes a brotherhood, an international brotherhood of nerds, right?
Yes. I like how you said it. It does. It does. It's funny you say that because I was just in Amsterdam and I flew here. I'm in Oslo right now. So like, as you think about going across the world, I'll be back in the United States. Like, you're right, Ed. Like, it's the International Brotherhood of Geeks. Like, what's like the it's like the what's like the Sisterhood of the Traveling Pants? What's the tech version of that?
Right. Yeah.
awesome. So, Bill, we're excited to hear you one more time. Thank you so much for doing that. We do have a nice surprise for the people who's going to be joining us on the on-site event. We have signed books by the master himself over here. That was nice. They made it on time. So we're gonna be giving those away. So thank you so much for taking the times and audience. We have 2 amazing speakers, and this is just the tip of the iceberg that we wanted to show. Ed, thank you so much for co-hosting with us right now. And then
Anytime.
Bill, all yours.
Perfect. I'll go ahead and take. Oh, there we go. There's that face. So, everybody, thank you again today for the opportunity to speak with you. This is great. You're seeing some brand new content. So I just came from DevOps Enterprise Summit and working in some content we do with the Investments Unlimited, some new content around governance engineering. You're really some of the first to see it today. So definitely excited to share this with you. I do have one rule when I do my presentations, and I call it my Beyonce rule. And so if you like it, tweet on it. So even if you don't like it, tweet on it and we can have an open discussion. So hit me up at Bill Bensing. But to get you started, the background of this, a lot of where Investments Unlimited came from was a lot of things from the DevOps Enterprise Summit, and it really started with sort of this love letter to auditors, and this is probably the only love letter that you can write inside of your organization to other people without getting in trouble by HR. But as we go through this, and as we go through some of this content today, what I want to do is I want to bring this sort of, we're sorry, dear DevOps, we're sorry, and we're sorry to compliance, audit, and security, and bringing them to loops and just showing how you and how we as organizations and as the community can make this happen. So a bit about me, outside of the opportunity to write Investments Unlimited, my background has been a bit of shadow IT. So I've been a hobby programmer, and then working in sort of the real software. There's a lot of software supply chain talk today, but I call it the real supply chain. Not that software supply chain is not real, but coming from the hard goods, logistics, and operations. So at the end, when I started my career, started building these small little applications as shadow IT. That grew, and then eventually I was able to give back to the community is start writing about the things and like the Phoenix Project. I remember reading the Phoenix Project and reading the goal and listening to Beyond the Phoenix Project as I'm doing all this stuff and getting the opportunity to write this book was such an amazing experience. And so hopefully on this new part of my career, I can give back to what a lot of the community has given me. So with that being said, enjoy the signed copies. That was fun. So Carlos and team, thank you very much for the opportunity to have sent you those copies. This was a real book about our real experiences. Of course, it's a bit of a fictional storyline, but a lot of things in there really happened to us, and so it was fun to write that. But as we get going, I always like to start my presentations with a bit of the bottom line up front. I call it the bluff. So I'm going to tell you what I'm going to tell you. First off, people should not execute the governance process. Machines must execute the governance process, but people are extremely important in this. People need to design, develop, and codify the governance process. And as I say governance today, what I'm referring to is security, compliance, and audit. And I don't think anybody's going to disagree with me on this one, but security in our governance is currently our bottleneck in software delivery right now. There's a lot of speak around developer tools and developer productivity, but developers can be extremely productive. But once it hits these gates of security, compliance, and audit, these governance gates, that's when things go out the window. We don't get to production any quicker just because developers can develop quicker. We have to take a systems thinking approach to how we approach software. And as we talk about modernizing software, we got to modernize our governance capabilities to address this bottleneck. Now, modernizing governance is automating the governance process, but, and there's one big but here, it's more than automation, it's autonomous. And stick with this key autonomous. And I'm not talking a bit about like AI in this at all, but let me describe what I mean as autonomous. The SRE book, the Site Reliability Engineering book, is one of my favorite books. Now, anybody steeped in Kubernetes, if you haven't read Chapter 7, highly recommend you read it because Chapter 7 talks about where Kubernetes came from and the evolution of Borg into Kubernetes. But in the beginning of Chapter 7, I love this paragraph, and I'll read some of the words out about go word for word, but it talks about SRE, about automation being a force multiplier, but it's not a panacea. You don't want to automate everything, but what you want to do is you want to, because if you thoughtlessly automate things, you can create as many problems as automation solves. But really what you want to do is you want to be judicious. You want a judicious application of automation. And that's what autonomous is. And when you think about designing autonomous systems, and for the folks around Kubernetes, you think about Kubernetes, you tell it what to do and it does it. It does it autonomously for you. So why can't we do that for our governance systems? Now, thinking through this, modern governance itself is a higher level system design. Going back one slide here, SREs, we start to think about autonomous systems are higher level systems designs. So that's where we want to get with automated governance. Now, modern governance, as I use this word modern governance, what I refer to as autonomous governance. And so with that being said, here's a agenda day. This is one deck I put together and I put a ton of material in it. So if you don't catch anything, I know this is being recorded, feel free to come back. But I wanted to leave you and everybody in Medellín with as much content as possible so you can take this and this deck back to your organization. I like to think that anybody could use this and rebrand it as a way to sell their organization. That's if you feel confident in this message, to sell your organization on how to do this stuff. So I want to make you the thought leader in your organization. So first off, let's kick off into the governance problem. So in most organizations, governance, it's toil. Security, compliance, and audit and toil. Now, security, compliance, and audit are bad. You don't want to get rid of it, but it's toil. So I want to define this word toil because I know we use it, and sometimes people don't understand where it came from. So back to my favorite book, Site Reliability Engineering, they talk about toil, and they define it as that kind of work that's tied to running a production service that's repetitive, manual, automatable, and it's tactically devoid of enduring value. But the biggest thing is that effort scales linearly as the service grows. One other quote I liked, I found in this same chapter was they talk about human operators. And I look, when you think about security, compliance, and audit, those are all humans right now. To a large degree, it's humans. And they have this quote around, if a human operator needs to touch your system during normal operations, you have a bug. And what I like about this perspective is it makes us think of our processes. So I don't think anybody has ever thought as our process being a bug if a human has to touch it. So I would argue is that if a human has to touch your delivery process between commit to production, your delivery process has a bug. And a lot of the organizations I've come from, and I'm pretty sure a lot of you, the organizations you're at, you realize this and be like, all right, our whole software delivery process is buggy. But that's something we want to fix. So let me talk about two types of toil here. I'll talk about governance toil and delivery toil so you can help identify these. So what is governance toil? Governance toil is just the humans turning the crank of the governance process. If I, as a developer, have to collect evidence to do a checklist, to send it to somebody so they can review the checklist, that's governance toil. That's humans turning the crank. That's stuff machines can do. But delivery toil, this is the more abstract or more confusing one, because delivery toil is caused by ambiguous outcomes of the governance process. So let's say that I get a checklist and I have to do this checklist. Well, if I don't know where to send this checklist, or if I send it to somebody and they send it back and they give me very vague instructions, now I'm spending a lot of time and effort trying to understand what I need to do, and I'm not developing software and getting to production. So that's delivery toil. So the governance toil is turning the cranks, and delivery toil is the confusion caused when turning the cranks. That's your two types of toil. And those are the types of toil that you want to eliminate. Now, because of this toil, what's actually meant to mitigate risks. So you think about the change approval boards and these types of human processes, they're meant to mitigate risks, but they actually increase risks. And as I say that, I do have the numbers to prove it. So let me go ahead and walk you through this. Now, as I say, this is something you could take into any executives. And if anybody back there is geeky and you're familiar with Bayesian theorems, this is basically a Bayesian theorem. But this talks about batch processing. And I'll go through this, but let's set the stage. Let's say it takes 2 weeks to get through your governance process. And let's say right now it takes 16 hours to get a new feature done. So every one feature is about 16 hours. And let's assume that every feature we create, they're independent of each other. So one feature one is not dependent on feature two and vice versa. And let's assume we're pretty good at doing what we're doing. And the probability of failure for that one change is 10%. So if the probability of failure is 10%, our success rate would be 90%. And now in most organizations, people will batch their changes because they can't go straight to production with one change. So they do the big thing and they create a release train. So we're going to go ahead and paste that release train to the pace of our governance process. This train departs about every 2 weeks because our governance process takes 2 weeks to complete, which means in 2 weeks per 16 hours per changes, we get about a total of 5 changes that go through our governance process. And remember, the purpose of the governance process is to reduce the probability of failure. So we should expect the success rate of this batch change to be no less than 90%. And arguably, it should be higher. Now, I know I can't hear everybody back today, but I'll take a stop. Think about this. Do you agree with this? Do you think these changes, these 5 changes, have a probability of 90% or greater for success in production? Well, if you think they do, you're wrong. And if you think they didn't, but you don't know why, let me explain it. The real probability of success is now 59%. So by batching these changes and going through, we reduced our probability for all 5 changes from, it could have been, if we were able to do what's called single piece flow, so one piece to production, we'd have basically a 10% chance of failure. Here we have a 59% chance of success, which means we have a 41% chance of failure now by doing this. And there's some simple math behind this. You just take 0.9 times 0.9 times 0.9. subtracted for one, that gives you a probability of failure. And so this is where some of this, so if anybody's familiar with binomial distributions, Bayesian math, this is how you figure this out. But let's just say that one change gets caught, say something happens and we increase the probability of success from 90% to 99. Well, by increasing the probabilities of success of that one change of 5, we only take our aggregated probability of success to 62%. And so what I want to show you here is this is just a demonstration of when you batch anything when you're delivering. And when people talk about bottlenecks, and when I talk about bottlenecks, what I'm talking about is this ideal of a single piece flow. I create a feature, I get it to production as quick as possible. So everything in the middle needs to be very quick and fast and reduce my time or the organization's time such that teams can release one feature or one small thing at a time to reduce the probability of any breakage in production. So with that being the problem, let's go ahead and let's talk about how we fix this. So solving the problem. Well, before we talked about automating that stuff, right? Sort of-ish. We want to autonomize things. Remember, not automating, we want to autonomize. We want to judiciously apply automation, which means we need to figure out what to automate and what not to automate. So how do we autonomize our governance process? Well, I got 5 principles to think through here as we start to do this. First, collaboration. This just can't happen in a vacuum. It can't be just developers or operations. It has to be really all parties, developers, operations, security, compliance, and auditors. Everybody needs to understand what's going on and how to achieve these outcomes. Second, enabling constraints. A lot of people don't like this word constraint, but to go faster, you need to reduce the amount of things that you're doing, which means reduce the amount of tools you're using, which means reducing the ways you work into very standardized, singular ways of working. Now, a lot of people are going to hear that and be like, oh my God, we got too many different ways. We know we have too many ways because we have to. Well, you need to critically look at what you're doing, because an enabling constraint enables you to move faster, reduce variability by constraining what you're allowed to do. Second, we're going to talk about requiring explicit evidence and idempotent processes. So as we go through our governance approach, we don't want things to be like, go talk to Bill, have Bill approve it. It shouldn't be upon Bill. It should be explicit. There should be evidence there that's factual data that any person, and this is where idempotent comes in, I can take that evidence, give it to 3 different people and a machine, and every time they should come back with the exact same answer. Now, governance execution is zero trust. I'm going to cover this here. Zero trust has been the big buzzword, but I'm going to go into a zero trust reference architecture from NIST and show you how to deliver in a zero trust model, as well as I talk about ephemeral and immutable. As we talk about this, we should be able to blow up these governance implementations and rebuild them from scratch. So as we go through this, we also need to think differently. We need to get away from the subjective change management, and we need to get down to verifiable continuous verification. Now, these are very big sort of corporate buzzwords, but this is evolution. You're going for some of the subjective sort of like, hey, Bill, go work with Carlos and Ed and see if they approve of this, to something that's more objective. You need attestations. Hey, collect this data, have different people evaluate it the same way, and then to continuous verification, which is having computers do this. Now, to achieve continuous verification, we need to autonomize our human control gates. And as we go through this, this is very simple. But as we start to think about autonomizing control gates, look at these black diamonds between your steps. Some of these are autonomized, some of them are not. Specifically, when you get more down towards deploy and operate, is where you're going to find a lot of humans in the process. So we need to look at this all completely and say everything from planning to operating our software needs to be autonomized. And we need to think about what we need to do to set enabling constraints such that we can autonomize this. Now, how do we autonomize these control gates? So autonomizing these control gates has 2 parts to it, and these are 2 simple steps. First, we're going to talk about evidence and attestation. So as I go through each of my steps, I'm doing something, I'm scanning, I'm building, I'm creating outputs that are evidence. I want to collect all that evidence, and I'm going to normalize this. And we'll talk about normalizing this here in a second, but by saying normalizing, we're going to convert this unstructured data or semi-structured data from scans and other types of machine-generated reports to something that's structured. Once we collect this evidence and we structure it, we want to sign it. This is an attestation. We want to say, okay, I as Bill state that we collected this evidence and this is factual for what we collected. Now, the second part is we'll talk about policy enforcement points, but at some point in time, we're going to have a policy, something like a policy as code. We're going to retrieve all this evidence that we talked about up in this first process, and we're going to compare those. And so these are the two basic things. The hardest thing to do is the first one, to figure out what evidence you need and how to serialize it, because that's a conversation. That's where that collaboration comes in. What do we need and how do we describe it? And the second is what gets to be pretty easy. This is where a lot of your policy, security, and compliance as code comes in. So to do this, though, we do need a new concept. And this concept is a governance contract. And so let me dig into this concept of a governance contract. So what is the governance contract? So here's the geeky definition. A governance contract defines the semantics and syntax of our governance primitives. Saying in a bit less of a geeky way, it's just how we codify our governance specification. So it's how we codify what we want to govern. And so what a contract describes is sort of like, if you look at testing here, and it's not just applied to testing, it's every gate, but this governance contract is a summary of what happened in testing, tool agnostic, technology agnostic summary of what happened in testing, such that we can determine at that black control gate if we pass that black control gate. So here's what a quick governance contract looks like. This is an example on the left-hand side. And on the right-hand side, at a minimum, this is a ubiquitous language. If you look here, it's tool agnostic. You see this says common vulnerability and exploits, but it doesn't talk about sneak. It doesn't talk about sonatype lifecycle. It just talks about the basic things we expect when we're analyzing common vulnerabilities and exploits. It's technology agnostic, like I said here, and it's understandable by technical and non-technical people. And this is, at the heart, a data exchange format. So these are sort of your minimum basics of what the governance contract needs to be. Now, I'm going to go through a couple of the basics of these. Every organization may have their own way. Remember, it's your semantics and syntax for how your governance process works. This is just a standard structure to think about how you structure this. So first is your governance procedure. This is the control gate required by your governance process. Second is the elements. These are the things that you want to look for that you need to measure. So for example, high severity CVEs, medium or low severity. And the third is the procedure element value. This is the count, or it could be some type of count. It could be a string that describes something, but this is a selection of what you want to evaluate and what the policy is going to evaluate. So let's talk about how we create these contracts. What you'll see here is an OSCAP scan on the left-hand side. And all I did was I took this semi-structured data and I serialized it into this CVE exploit, this governance contract on the right-hand side. So once I create this contract, what do I do to evaluate a policy against it? Well, on the left-hand side here, something like OPA. There's so many different types of policies engines out there. What I can do is write some of these standard types of policies, codify these, and these are the things we work together with our governance counterparts. We codify these, we source control these just like code, and then as you go through all of your gates, as long as you agree to what's on that left-hand side, it evaluates what's on that right-hand side to determine whether you pass or not. So what does this look like when we apply this to software delivery? Well, you have continuous integration now becomes evidence collection. So as you notice, as we're going further into this autonomizing governance and modern governance, we're expanding the roles of continuous integration in continuous deployment. So continuous integration becomes a first-class citizen. A first-class feature of it is evidence collection of what you're doing. Now you get into continuous deployments. As you go into deployments, whether it's a new dev or test environment, you are validating that the software meets the expectations to be in that environment at every different level. So it could have low expectations at dev, but as you go higher, it can be higher expectations. One thing to see here on the slide is as you go in, we talk about auditing and attestation before you go into the actual environment, you'll see that things such as we can validate the environment configuration, we run user acceptance tests. Now the outputs, the material, the evidence from these user acceptance tests can be used to evaluate if you move to the higher level environment as well. So imagine running automated tests in pre-prod to see if you move into prod. And that can be testing anything, not just the software, but are we testing different types of configurations? What are all the things that we can automate and evaluate that we ask humans to do? Now, if you put these two together, what you get is you get 100% automated audits. So this is just automating your audit process through CI and CD using the same approaches that we do as humans, but we're autonomizing them. We're identifying the evidence we need, we're serializing it, and then we're evaluating it against policy as code. And all of this is cooperatively designed through the governance aspects of the organization, as well as developers and operations. Now, this is the business outcome. And the number one thing that I've learned through my tech career is like, I can talk geek all day long. When it comes down to C-suite, it's all about business outcome. It's all about revenue and risk. So if you're familiar with SOC 2, SOC 2, SOC 1, SOC 3, and type 1 and type 2 controls, this is also with things like ISO. When you achieve something like this, what we just showed, you can now just do real-time audits. Instead of like waiting 2 or 3 months or 6 months to do an audit, you can do a type 1 and type 2 audit on the fly of what's happening before it gets deployed. So this is where you reduce the amount of money that the organization's spending doing these audits, because we know, and anybody who's been in a highly regulated organization, they can spend millions a year by having people come in just to double check that you're doing what you said you're doing. So these are the types of business outcomes that can be achieved. Now, I talked about some lists of gates. Here is just other gates that could be autonomized: code review, unit testing, anything in here, but anything where a human's being asked to, hey, review this, go through this, that's what you want to autonomize. All right, so getting down to a solution, we just sort of covered a problem, we covered some principles, but really it's got to a solution, what you can do today to implement this in your organization. A lot of people are starting to hear about golden paths on the Netflix on-road and the off-road, some of these things around internal development platforms. This is what you want to start striving for. But the thing about golden paths that people talk about is they generally talk about tools and things around developers, but they don't think about compliance, security, and audit, the governance aspects. So what you want to do is you want to solve the software delivery process with a software delivery approach. And when you create golden paths, you're creating on-roads for the whole organization, not just that consider the whole organization, not ones that just consider development or operations. One warning I like to put out there is be careful. Golden paths are not golden cages. A golden path is something you want people to follow. A cage is the only thing that they can use. So think about like being enclosed in a cage. In organizations, there is sometimes a legitimate reason, business reason, to not go down a certain path. And let's accept that. But what we want to do is we want to try to build the standard amount, a standard or a good amount of paths that people can follow without having this infinitely amount of ways that people can deliver software. So let's talk about building a golden path to production using governance as a service. So I think this looks probably familiar to a lot of people. Different teams, you build, you test, you do your scans, you deploy. But before you can get to that mythical production environment, you got this mother may I, security may I, compliance may I, audit may I go to production. This is where things back up. This is where the queuing happens. And this is where the risk is introduced. Now, these individuals, they're great, they're smart, they're talented. And it's not their fault that risk is added. It's just the physics of the process, that because you're batching all these changes, you are increasing the probability of failure and reducing the probability of success. So let's look at something that's a bit more pulling these folks out of the way. So what you'll see here is you'll see GAS. GAS just stands for governance as a service. What this is think about it as a separate pipeline, which you notice I've pulled a lot of scans out. So building and testing is really where the developers are going to get their feedback from. But all this other feedback, these large amounts of scan, CVE, that kind of stuff, developers really just need to be told what was wrong and why and how to fix it. They don't need to know about all the tools under the hood. So let's abstract those tools, put it in its own internal service. And this is where it basically can determine on real time if the software is compliant enough to go to production or another environment. Now, what you're seeing here is the introduction of this thing here called a gate. And why this is important is because remember I talked about earlier about zero trust? This is an implementation of the NIST 800-207 Zero Trust. So the governance as a service is that control plane. It's the policy engine, policy administration. That stuff on the right and left-hand side, that's your evidence, that's your material. Here you're seeing things around identity, PKI, and ID management. But in a software delivery process, it's identity and CVEs, software composition analysis, other types of metadata like that. And then your policy enforcement point is this thing between production and then your system, your CI, and your user, which is your the subject, which is your developers and whoever it may be. And then production is your enterprise resource. So if we go back, you see that this is how you can apply zero trust to your software delivery. But let's dig in just a little deeper. Here's what a governance pipeline could look like. You have SAST, static code analysis, dynamic code analysis. You could have any types of compliance checking. You could have software composition analysis, all of these other types of evaluations. And then what you see here is an attestation. So there's a couple key components to this. Outside the gate, you have an evidence repository. So you're recording every time one of these tools creates some type of metadata. Now, the tools will store the metadata themselves, but you want a copy of it. You want to copy it at the time it was created, so you have an unadulterated copy in the future if somebody wants to come back and look at the evidence. Second, you have compliance, security, and policy as code. This is where you codify your expectations. And third is the attestation. Now, the attestations are key because what happens, this is where the machines look at your policies and your evidence and your governance contracts and determine if it meets expectation. If it meets expectation, an attestation can be made that says, hey, this piece of software meets these special expectations. And then that's how the gate can determine if it goes to production or not. So the gate will be looking and saying, okay, to get to my production environment, I expect A, B, and C. It will go look for attestations of A, B, and C for a given piece of software. And if it goes to production, if it works, it goes to production. All right, so digging deep, we talked about a bit of the solution, and that was the technical. But let's talk a bit more about sort of the people process, governance and engineering productivity. This is interesting. So this is getting further and further away from the time I've been using this. This was the State of DevOps Report 2021. But a lot of, even today, and this is still not just, it was not valid back then. It's still valid today about 2 years later. A lot of companies are stuck in the middle. They're failing. They've started some level of DevOps. They've hired and they've trained teams, but they're stuck because they really haven't created cultures of knowledge. And when I talk about cultures of knowledge, really what we're talking about is platforms. What these all have in common, and people talk about internal development platforms, developer platforms, this concept of platforming. And what you're really doing is you're bringing the knowledge that's created by these different teams into a centralized capability that can be reused. And so what the State of DevOps report saw back in 2021 was that teams that were performing the best in the survey, they had forms of development platforms, and they were recommoning this knowledge. Instead of it being in a person's head, they were codifying it. And the thing about a platform is it provides enabling constraints. So they learned, they observed, they converged on these constraints, and then they implemented them for the organization. Now, this is not new. What you're going to see here is a YouTube list of things I put together in the fangs of Facebook, Apple, Netflix, Google, Amazon. These are called engineering productivity teams. So people, and this has been coined since about 2007, 2016. And what you'll see here are just the engineering productivity teams that are at Netflix itself. Now, you need an engineering productivity strategy. What an engineering productivity is, it's the organization setting aside engineers to solve other problems, whether it's software delivery or not, for other engineers in the organization. You see things around platform engineering becoming a popular term, internal development platforms. These are just approaches to make it happen. But the bigger, the more human focus is, how do I start to set up these internal teams that help my developer teams do things better and then recommend that knowledge? Now, the biggest thing here is always getting back to the business is, you know what business problem engineering productivity solves? It solves for top line growth of the company. Now, this is a big thing. So you're talking to your CEO and specifically your CFO. Everybody talks about faster, more efficient, but nobody really talks about creating top line, more revenue. So as you start to think about engineering productivity, we start to think about autonomizing governance. What you're doing is you're freeing up resources that are other engineers and developers and other people in the organization. Now, these resources, they're going to do what humans do best. They're going to be creative. They're going to create new things. And when you create new things, you increase the probability of selling new services and products, which those are top line revenue. So this is a tie back to the business outcome. And when you do these things well, you make the right things the easy things to do. And so in highly regulated companies, this is just a general reference architecture I put together a little while ago, that what these internal development platforms could look like. Cross-cutting concerns such as monitoring, compliance, security, identity, and access management. You have your tools under the hood, but what you're going to see here and what I want to focus on are these canonical workflows. Because these canonical workflows are the products your engineering development or your engineering productivity teams that they develop. And here's what they look like. It could be day one stuff such as onboarding or offboarding engineers. So how do you automatically onboard an engineer? How do you help them create an automated new application? How do you help migrate existing applications to new ways? And then we have a lot of people that leave, but what about offboarding engineers, capturing their knowledge and closing their systems down? And you have the things like day two. So this CI, CD, and other operations come in. So such as standard workflows for CI, for CD, and then also governance as a service, because you may have multiple governance pipelines based upon your needs. So this gets back to sort of where I want to begin to end the presentation, governance engineering. This is a new thing. You're going to start seeing me talk a lot more about it and hopefully a lot more in the industry. And I'm going to tell you that you need governance engineering. Now, besides the new pithy buzzword, what is governance engineering? Well, it harkens back to my favorite book again, is the site reliability engineering book. And I love these Google books because it doesn't tell you just what they did, what Google did. It tells you why they were successful and areas that they learned from and why they learned. Now, if you look at chapter one, Ben Trainer-Sloss, the fellow who created SRE teams back in 2003, he was asked, what is SRE? And he just basically said, SRE is what happens when you ask software engineers to design an operations team. So me, I like to borrow from people. What is governance engineering? Governance engineering is what happens when you ask a software engineer to design a governance team. So that's why we need governance engineering. Now, it's not just a software engineer pushes everybody out. What you want to do is bring a software engineering approach to the governance approach of your organization. A couple things I'll show you which are neat and interesting and how you can get started. On the left is the site service reliability hierarchy. For anybody doing SRE, this is the basis. You see monitoring, incident response. This is how you start to formulate your SRE approach, going from the most fundamental things such as monitoring to the top. Well, I took this and I redid this for governance. There's 4 new aspects: governance monitoring, governance incident response, governance procedures, and then governance or control planning. So let me talk quickly about each one of these and what they mean. So governance monitoring. Monitoring is always a foundation. You want to be aware what's changed in your environment and what's supposed to change in your environment. So as you start to think about monitoring, you want to monitor what's changed and what's supposed to change to determine if it should have changed. Next is governance incident response. You want 100% real-time forensics. So as incidents happen, how can you get to the evidence, to the information as quick as possible? And I'm talking about just outages. Imagine a new CVE happens. Where are all these CVEs? Where are all the applications running in my environment that have the CVE? So how do you quickly identify, resolve, and get to root cause? Third are the governance procedures. Now, I use the word procedures. If you're familiar with the secure controls framework, this in there, but this procedure, this is the automated thing, like automating the evaluation of a unit testing, automated the evaluation of a CVE or a software composition analysis scan. These are the things where you 100%, this is how you automate the gates. You automate the reviews and the evidence collection. You codify all of your standards and guidelines, and then you have to ask yourself what other controls and procedures need to be automated. Now, the fourth is control planning. The first 3 were the geek things. Now, the fourth is really where the return on investment comes in, because this is 100% human focus. By automating all of those 3 other processes and removing the delivery and governance toil by automating and autonomizing those processes, what you do is you reallocate those humans to focus on what they do best, which is being creative. Now what they do is they can look at their controls, they can think about controls, and they can say, do the ones we have, are they effective? If they're not, what needs to happen? So you refocus their effort on looking at the system, the governance system at large, and asking, is what we're doing the best thing for this organization? I won't go through each of these, but I did go through I took the golden signals, basically said, what would some governance golden signals look like human touch points? How many times does a piece of application gets touched from commit to production? Audit tack time. So this is how long does the audit take? Control ambiguity. So the amount of controls you have, which ones do you know apply? And which ones are you like, yeah, I'm not sure if they do or don't. And then control coverage. If you've got 1,000 controls and you've only got 900 applied, so you think about unit test coverage, it's a bit of the same thing. And then getting even more cheekier, you can get down to same thing as service level indicators, governance level indicators. What's a good indicator, a good metric to say I'm doing good? What's my objective to be at or between for that indicator? And do we have agreements with our organization, something that I'm either contractually or there's some obligation I'm held to? Now, in closing, one thing I want to hit on here is we need to be adopting the mindset of engineering productivity in governance engineering. Engineering productivity is about a specific focus and investment on engineers engineering things for their organization, for other engineers in their organization. And governance engineering is about solving our governance problems. Governance engineering is about solving governance problems with an engineering mindset. One thing I'm going to tell you is to repurpose your change approval board. I think you all like to hear that. But I'll tell you what you need to do is actually replace your CAB with the governance engineering team. So you don't get rid of it. Use that as the resources. Replace that, upskill that team. Use that as the set of collaboration to start creating this approach. Remember, site reliability principles, they're fundamentally the same thing as governance engineering principles. If you look at them one-on-one, reliability is just worry about uptime. Governance is worried about compliance and security. So as I end this, just remember that no matter the road traveled, where it's an on-road or an off-road, always apply the same governance. What you want to do is to modernize your governance, you need to autonomize it. And to autonomize your governance, you want to do that with governance engineering. And with that being said, gracias, Medellín. It was wonderful. Thank you very much.